Hey everybody, Jeff Oriema here. Welcome to Schema Workshop, where we design an API around a set of realistic requirements and constraints, trying something new each time. Okay, so let's look at the requirements here. Clinic visit scheduling. So right off the bat, clinic visit scheduling. So we're looking at some sort of time-based, like a calendar-based application. It's likely to do with something medical, I would imagine. Let's go down to the context. A clinic schedules visits between patients and providers. Okay, many visits are one time, a good number are recurring, physical therapy every week, a medication check-in every month, and so on. A recurring visit is set up once, but its individual instances don't always stay in lockstep with the original plan. One visit might get moved to a different day, assigned to a different provider for just that day, or called off entirely without touching the rest of the series. The series itself can also be called off outright, which should stop it from generating any more future visits. Okay, so like a lot of calendar functionality here, obviously, but we need to know the state of each visit, and obviously there's some specific contextual information that we would want to know about the appointment that should be there. Okay, let's go to the ask. Give a client enough information to answer, what does my schedule look like? Fair enough. For a given patient over a date range, a client must be able to determine per visit when and which provider the visit is actually scheduled to happen, not just the original plan it may have come from, whether the visit is part of a recurring series, and if so, which one, and what that series' overall pattern is, the current status of that specific visit, whether the series itself has been called off independent of any individual visit's own status, interesting, and if the visit belongs to a series, the rest of that series visits, so that a client can show, for example, this is one of 8, here are the others, and let someone act upon just this visit or on the whole series. Well, at least there's no time zone requirement. So there you go. Silver lining. Constraints. Okay, very important. Visit may stand alone or be one instance generated from a recurring series defined by a repeating pattern, frequency, day and time, and either an end date or a fixed number of instances. Fair enough. Any single instance belonging to a series may be individually moved to a different date, time, or provider, or individually called off without changing any other instance in that series. Series may be called off as a whole, which stops future instances from being generated, but must not retroactively change instances that already happened or that were already individually modified. Client must be able to tell for any given visit both what happened to that specific visit and what happened to the series it came from. Independent facts. Okay. Not the easiest thing in the world, but luckily we're not having to implement the API itself, just the API schema that will allow it to happen. So with that said, let's go ahead and change gears. We're going to start designing this API. So as y'all know, I am a big fan of the dream query method. So on the right-hand side, we have a schema, a GraphQL schema. I've just pre-filled it with some very, very basic data. And on the left-hand side here, I have a query scaffolded. It's called patient schedule, and it just has a couple of variables spelled out here that we think we're going to need, like the patient ID, like a from date and a to date. So some basic kind of selection variables there. But otherwise, we're starting from a blank slate. So let's get started here. Again, we think about this from the point of view of the person using the API, right? How are we serving the end user? And Dream Query is a really good way to sharpen that thinking and to think, okay, how is the client, whether it's an application, whether it's an agent, how are they going to actually be interacting with these services? How can we make it ergonomic for them, based and rooted in their needs, their concrete needs, rather than some abstract best way to model data coming from, like, say, our services or our database layer or something like that. We approach this from the user's point of view first. So let's go ahead and start with the basics, right? We don't know everything here, but we know we want to get a patient schedule. So let's posit a name, patient schedule, like a root field. Schedule, I can write. Excellent. So we have a patient schedule, and we'll go ahead and parameterize it with the patient ID. Then we'll have a from and to right now. And then we'll open those braces and start thinking about fields. It's always good hygiene when you're thinking about modeling data to expose the ID of an item to the client so that they're able to use that information. It's a great mechanism for creating unique identifiers within a document, things like that. We're going to look for an ID. So obviously for each, this should be a list, right? So like we can do a list of appointments, I suppose. And for each appointment, it'll have an ID, obviously, and we'll say we need to know who's coming, right? Or who we're seeing, which provider. So let's just put their name in there for right now. Maybe an ID too. We'll just, to keep it terse, I'll go ahead and leave out the ID field because we already addressed that in the parent field. Great, and let's go ahead and say schedule that. It's probably important, like when did this appointment actually come into existence? What was it created? And the appointment status is probably important, some sort of status thing like, we want to know if it's canceled or postponed. Has it been moved maybe? Was it rescheduled or was it completed, right? Is this in the past? This is all, I think, material information. So again, we're going to take a few passes at this to try to sharpen up the use case because we have a bunch of requirements, but the dream query and the schema are sort of exist in a dialectic, right? You go a little ways with one, and then you go ahead and, you go a little ways with your dream query, then you take a look at the schema, see what you can design there. And when you kind of reach a natural stopping point, you iterate and try to make it better and better. So I think we have plenty to sink our teeth into here. So let's go ahead and move to the right-hand side to our schema. All right. We know that each of these items here, this is like a list of appointments. So let's start by giving us an appointment. What does an appointment look like? Well, we know we have our ID and our scheduled at bit and everything like that. So ID is an ID, clearly, and a scheduled at would be a date time, right? It would be a nice timestamp there. We will have to say, well, of course, we'll have a provider, and that'll be a placeholder because we're going to need another type for that. Provider, I don't think we've done that, but each one has to have a provider, right? I'm trying to make these design like the nullability rules, and I think we can guarantee that if our service is running, each scheduled at bit will be non-nullable. Each provider should be non-null, right? So that'll be good. And then we have the status bit, and I think we're going to need an enum for that. So we'll just call it an appointment status. And I can't imagine a null status here. I like to do enums right away. And let's just say, well, completed is in the past, right? So that's good. Canceled. So if it's been scheduled, then it's scheduled, right? Like it's pending essentially. And I'll call this rescheduled. So like one of the requirements is that each of these appointments can be independently moved, and we want to know which one has been rescheduled. So then when we look back, we could see which ones are essentially quote unquote normal and which ones are sort of an exception to whatever rule we have. All right, cool. This feels right. Now, oh, well, we have a provider, and even though the patient's schedule right now isn't asking for it, I would imagine that we'd want some sort of patient object as well. So let's design that at least, and maybe update our dream query in a little bit. Okay. So I think this appointment bit, I stubbed out this visit type kind of as a throwaway. And I think the appointment bit is what I actually intended for this visit type, but I think appointment is probably a better word than visit, because maybe in the future or maybe currently we support like virtual or something like that. So that wouldn't imply a visit. So I think semantically I'll say appointment. And then for this patient schedule bit that I stubbed out, it will be an appointment, a list of appointments. Each appointment should not be null, right? Hence the bang. And at the end, this list should not be null either. I would expect just an empty list, not a null value. So I think these are all annotated correctly. Maybe in the future we'd add some default values or something like that to the parameters, but right now let's keep it simple and leave these be. Okay, cool. So looking back here, I think this is pretty pleasant, but if we go back to the requirements, right? Let's see, when and with which provider the visit is actually scheduled to happen, right? Okay, great. Whether the visit is part of a recurring series. So I don't think we've captured that requirement yet. Current status of that specific visit, I think we've captured that in our schema so far. Whether the series itself has been called off, independent of any individual visit. So I don't think we have that yet. And if it belongs to a series, the rest of that series visits. I think we have that here, but there's probably a better way. But at least it gives us a little bit of direction as to, where to go next. So looking ahead, how can we make our dream query more representative of what we actually want this experience to be, right? Well, I think right now we need some sort of semblance of an awareness of how the series actually works in practice. And for that, I'm going to postulate something called a recurrence rule, which is something borrowing sort of from CalDAV here, representing calendar events and things like that. So recurrence rule. And whenever I think of a recurrence rule, I want to know frequency, right? Like how often or not often is this actually happening? Day of week, we'll say. There's a million ways you could do that. Days of week, etc., etc. But let's keep it simple for right now. Time, the end date of the recurrence rule, and or the occurrence count. So if I see this, all of a sudden I get a much richer representation, and I'm getting closer to the requirements. So if I can expose this information out of the schema, I think that would be helpful. So to our appointment bit, I'm going to go ahead and add a recurrence rule field, and that'll expose a class recurrence rule. Now, not every appointment will be a part of a series, right? So I do think this is legitimately nullable. So I'm not going to annotate it with a bang. Let's go ahead and create our recurrence rule type. Okay, and for each of these, we've already stubbed these out. Frequency. This probably shouldn't be arbitrary. We should probably make an enum. So we'll call it a recurrence frequency. We're going to need to specify that, so we might as well. So how do we want to model this? We can make it as simple or as complicated as we want. Because this is for a video, I'm going to keep it simple. I'm going to go weekly. And we'll call it bi-weekly. Probably should call it fortnightly, but bi-weekly is a little more terse. And monthly. So every week, every 2 weeks, every month. Okay? And that always needs to be there. If there's a recurrence rule, it has to have a frequency value. Day of week. Let's model that as an integer 0 through 6, I suppose. Time. Now, this is interesting. Probably just make it like a date time, maybe. And everyone will have one, so we're going to go ahead and do that. Start date. We'll go ahead and just make that a date, I suppose. I don't think it needs to be down to the time level. End date. And doesn't have to have an end date, right? And an occurrence count. and that'll be an int as well. And again, we don't have to specify these, right? This could be an infinity type of deal. Let's add start date to our Dream query too. I mean, it probably helps to know how far back the series goes. All right. So now we've specified this, and we all of a sudden are getting closer to our requirements. Now, an interesting wrinkle here and a design flaw maybe that comes to mind is that we are putting the recurrence rule directly on an appointment. So every row that we generate in the same series carries its own kind of independent copy of the rule when we access it. No like sort of shared identity linking sibling visits. So there's no way to say like, show me the rest of this series, and no way to cancel a whole series in one operation. Like this is sort of a clumsy representation. So I think we need to do something about that. I'm glad the information's there, but it's certainly not in a state where it's going to go ahead and be as useful to us. So let's refactor a little bit. I want to encourage, or I want to postulate a new object called like series. How about that? Like instead of having that be implicit, we'll nest this recurrence rule inside a series object, and each of these series objects will be individually identifiable with the recurrence rule, obviously, and the visits. Okay. Now this will be kind of interesting because I think this has some design implications. For each visit, obviously each one would have an ID, and I think we might be starting to take some state out of the individual appointments, and maybe we're talking about a patient schedule actually being its own object, its own single object, and instead of a list. But let's see where we can go here. So at the risk of duplicating right now, let's go ahead and populate out this bit. And this scheduled at bit for each of these visits shouldn't cancel out anything else that's here. But I wonder what the fate of start date and end date are. All right, I'm starting to talk in circles. So what if we go ahead and what if we go ahead and start at the schema? Maybe some of the details will reveal themselves to us as we start to design. So where to begin? So maybe a series is probably the place to start. And each of these series, let's create a new type. Let's call it type appointment series. It'll have an ID, it'll have a patient, of course. And we still haven't designed a patient object yet. We're gonna have to get there. We're gonna have to do a provider. Okay, now this is interesting. Now I'm thinking back to the requirements, right? And I think I remember something about multiple providers. Hang on. One instance for a recurring series, any single instance individually moved to a different date, time, or provider. So I suppose when we're making a series, we'd have to designate a default provider. Right? It might not end up being the individual that's in each specific appointment instance, but certainly we would have the notion of sort of a regular or default provider for this. And here's where we put a recurrence rule so that we can access that, right? One of the main problems with the other one was the recurrence rule was sort of nested within each appointment instance. So here we're going ahead, putting it on a specific entity here. And then we're going to go ahead and call this appointments. We're going to go ahead and say appointment. It's a list of appointments. Great. Excellent, excellent. Okay, so we have our series now. And it's able to support this. Oh, and I just realized I mixed up my vocabulary here. I did visits when I should have said appointments. Okay? In the dream query. So now that we have appointments here, we can go back and start to correct our homework a little bit. Let's take stock here. And let's just take this opportunity to specify provider and patient. I don't think we've done that yet. So type provider and type patient. They'll have similar members, at least for right now. We'll just say patient is an ID and a name. Nothing remarkable here. Again, this is ultimately for a video, so I'm oversimplifying things. And for the provider, we'll do similar things. A name is a string, and we'll just give them a specialty. So we know if it's like physical therapy or something else, and we'll make that optional right now, nullable. There is an opportunity for polymorphism here, but that might be a little overkill at this point, but you could do something like an interface of a user or something like that. And make the provider and patient implement that. Probably not necessary at this point, but I wanted to point out that would certainly be a valid way to design this. All right, we're getting a little closer now to where we want to be, to meeting these requirements. And I really feel pretty good now that we have this idea of a series with a sort of default provider. Now, we're not querying for it yet, and we can always go ahead and ask for that default provider here. I also see like recurrence rule here with a start date and end date. Probably still want that. So, okay, looking at this, I think it's time to switch back to our dream query and fill out some of the details. Okay, let's take stock of where we're at now. For anybody to get a list of appointments, right, for us to be able to do all the things the requirements tell us we need to be able to do, our entry point is through an individual appointment, right, or a list of appointments. And each of these appointments exposes, a certain amount of information. We have information about the specific appointment that we're asking for. We have our provider information, all that good stuff. And then we have information about the other appointments in that series and about the series itself. So even though our entry point is a list of these appointments, I know I hinted at a singleton before, but I think we're in the right ballpark here. We go ahead and we get this list of appointments, and each of them you can then drill down to get more information about the entire series in the entire context, and then go from there, right? You can go deeper and deeper if you'd like. So I think this is the right overall design. We might want to add some optimizations to this appointment list. And I think originally scheduled at would be a really good quality of life addition, so that folks can understand what, at a glance, not just the status of whether it's been changed or not, but also when that appointment was made. And I think that would be useful for everybody to know, like, if there's a last minute change or something like that. So I think in the appointment bit, we need to add an originally scheduled at bit. It's a convenience. I don't think originally scheduled at needs to be there in order for this to be useful. So I actually think nullable is the way to go in this particular type. So I'm going to go ahead and make this nullable on purpose. That's good. And then back in the dream query, I think going ahead and adding that to the original entry point here, originally scheduled at, would also be a good convenience for the patient. And it just occurred to me the default provider needs to have a name at least. Let's double check with the requirements though. Okay, I'm going to go down to our constraints. I think I have a pretty good sense of this. Individually move to a different time provider. I think we have all this stuff there. Okay, here it is. Third constraint. I think we're missing this one. A series may be called off as a whole, which stops future instances from being generated, but must not retroactively change instances that already happened or that were already individually modified. So I think we need a status rule then, so the client can indicate to the user when a series has been canceled, essentially. So I think for the series, we need a status field. So for appointment series, let's go ahead and add status, and we'll call it appointment. Maybe not. We'll call it series status. What would be the right one? Let's call it series status, and we're gonna have to make that required. And let's go ahead and make that series status enum. And I think we can keep it simple here. Is it active or is it not active? We'll call it canceled. And I am just noticing that we're missing something in the schema. We have no way of accessing the series from the appointment bit, so we need to add a series field. And we'll just make that an appointment series object. And because the series or appointment does not necessarily need to belong to a series, we're going to leave that null. Okay, super. I believe we're all set for a requirement. Okay, so I set up like a quick mock server with some stub data here, and it's just an Apollo server instance. And I'm in the schema visualization tab of Sandbox here. I love taking a look at the high-level design of an API that I work on. It's a great way to get clarity on what we've created. And so here you can see, when we're querying for a patient schedule, we get a list of appointments, right? And each of those list objects gives us like, okay, here's Monday's appointment. And it has the ID, right? Scheduled at, originally scheduled at, the status of that appointment, who am I, who is the provider, right? Or I guess if I'm a provider accessing this, like who's the provider, who am I, and who's the patient I'm seeing, recurrence rule and series information. So each of those, series information goes ahead and points to this appointment series bit, and then we can see, key info about that, right? How it recurs, right? Who it's supposed to be with, or the default provider that's supposed to be in that series, and the status of that series, whether it's active or not. Patient and provider, pretty straightforward. And then, each of both the individual appointment and the appointment series both can contain a recurrence rule. And I think that's very helpful in a way. I do wonder whether the individual appointment needs a recurrence rule, but I could see when you're kind of looking at it like, hey, here's my weekly appointment with so-and-so, but I might have a monthly appointment with so-and-so, with a different so-and-so, right? So it might be useful to be able to see at a glance for an individual appointment instance what the recurrence rule is, even though that's sort of the domain of the series. I can see that being helpful. So I would keep that actually. And this is, I think, the big benefit of looking at a representation of your API design here, a high level representation. So there we go. And I would love to just see, our appointment or our query in action. So I've copied it and I'm going to paste it in here and give it our variables. Again, this is stub data, so the variables are throwaway, but I'm just going to say patient one. We're going to call it from, we'll say the first half of 2026, just as a stub month. Again, it's going to return the same data no matter what, to the end of June. And let's go ahead and execute that. And you can see here in the response, we have a bunch of statuses, an ID, right? Our timestamps, our provider information, and so forth. Very exciting to see this live. So there we go, from 0 to patient and provider scheduling API. If you made it this far into the video, thank you. Leave a comment. Let me know what you think about Schema Workshop and what kind of challenges you'd like to see in future videos. And please don't forget to drop a like in there and subscribe. I publish Monday through Friday covering APIs, GraphQL, artificial intelligence, and more. That's it for now. See you next time.